hand here.
We're still talking about math.
Okay, so let's do 1.8 review exercise here. Let's go over some of these questions, okay? So this one right here is just like the question number 1 on the quiz, or number 2 on the quiz, I guess. So let's take a look at this from your review exercise in your text. So this graph is in your text here, and there's some questions about limits regarding this graph. So let's just take a look at this. So A, first of all, the notation, the limit of f of x, that's the red graph here shown above, as x approaches -1. If there's no little plus sign or minus sign behind the 1, that's a two-sided kind of regular old limit, right? So where is x 1 equals 1? Sorry, -1 is over here. And if we look at the graph, not at -1 necessarily, but what is the graph doing as it approaches -1 from the both sides? Is it centering in on a value from both sides? Yes, it looks like it's +1, a y value of +1 here. Everybody see that? So you block out this part right here, and you look at the graph on either side of the block out there. If the graph is centering in towards the same y value right here, which it is, then that's your limit. That's your two-sided limit. Okay, B over here. X approaches +1 from the left. So there's a big difference between this notation and this notation, right? This is +1 from the left. So +1 is over here. Again, I block out +1. What is the graph doing right here? What are the y values approaching as we approach +1 from the left? It is 0. Right on. Awesome. What about +1 from the right? Again, I block out x equals 1, and I look at the graph now. So from the right, as x approaches 1 from the right, what's the graph doing? It's approaching a value of -1. How you guys feeling about that? Pretty good?
Yeah.
Okay. So what's the limit of f of x as x approaches 1? From like the two-sided limit? It does not exist, right? Why?
There's two separate y values.
Yeah, the left-hand limit and the right-hand limit do not agree. So it does not exist, you can just say. What's the limit? Does not exist. There is none. Okay. So value of 3 here, -3. 1, 2, 3. Here's -3. From the right side, this is the graph approaching, looks like y of 3. X approaches 4 from the left. Okay, it looks like it's approaching a value of?
2.
Yeah, I think that's 2 there. That's a 2. Good. And 4 from the right looks like it's approaching 2 as well. Does that make sense? Now, do you know what this shape is of this graph here? That is actually a cusp. Okay, a cusp where it's concave up like a cup here, and concave up like a cup here. That's a cusp. This is like a corner where it's a straight line. That's a corner like an absolute value or something. This would be a cusp.
Down like a tree.
Yes, and where it's concave down, so it's concave up like a cup, and this is the same concave down, concave up like a cup, concave down like a tree.
Guys, we should have been on our tile, right?
Yeah.
Like a tree.
Okay. That was your brilliant idea for this class, wasn't it?
Yeah.
I used to say down like a frown, but what do I know? Down like a frown, you see? Look at here's down like a frown. Look at the frown.
Well, didn't you draw the big pretty tree? That looks kind of like a tree. Oh,
Look at-
Looks like a tree.
See, it's a frown. Oh, look at.
I like your
Looks
tree
like a
drawing.
tree like on the side.
Still seeing a tree.
Look, it's about to cry.
One ear.
One ear? That's not an ear. That's hair.
Actually,
Here's his ear,
trees
fine.
don't have ears.
It's not a tree. Thank you.
Shrek.
Okay.
Yeah.
Looks like Shrek.
Yeah.
It does not look like Shrek. I don't think Shrek has hair like that, does he?
So are trees.
With the big.
So
Okay.
Hey, yo,
Guess what? This lesson is not going well right now. It's going in the wrong direction. This is concave down. Okay. It's becoming negative. Okay. All right. One more. Limit as f of x approaches 4. Well, from both sides, it's the same left-hand and right-hand limit, so it looks like it's 2. Okay, so here's 3. Find the following limits. Guys, listen, if you can just plug it in, plug it in. If it's evaluated, plug it in. Especially, this is a polynomial, A, so that means there's no restrictions, there's no gaps, anything. It's just a polynomial, it's continuous. So plug 2 in, you're good to go. So for A, this limit is equal to 3 times 2 cubed plus 7 times 2 minus 16. Or 3 times this is 24 plus 14 minus 16 is 22, looks like. Okay. Now the tricky part comes when you have a rational, right? So maybe let's take a look at D together. D. So, okay, so D, now if I plug 4 in, do I have a problem? Can I just plug 4 in? Well, that's 16 minus 28 plus 12. So 16, oh wait, what? Is that okay if we just plug it in? 16 minus 28 plus 12? That's going to be minus 12 plus 12? Is that right? Okay, so now what we need to do is we need to factor both top and bottom. So if you can't just plug it in, if it yields a 0 or whatever, factor the top and bottom. So trinomial, that's going to be what? X minus 4 times x plus 2. That's what multiplies to negative 8 and adds to negative 2. And then this one is going to be x minus 4x plus 3. Right on. So this is great news. I can mathematically alter this rational to make it look like something else. And then I can use the limit here for this one, x plus 2 over x plus 3. And then again, remember, this function looks actually like this when it's simplified. It just, this one doesn't have the gaps or whatever that show up in this one. Yeah, question?
Shouldn't it be x minus 3 on the bottom?
Oh, x minus 4 minus 3. Yeah, thank you. That should be a minus 3. Right. I wrote a plus.
Wait, why is it minus?
Well, because this is positive and then this is minus. So x minus 4, x minus 3. Yes, you're right. Thank you. So now we can just plug that in, and we've got 4 plus 2 on the top and 4 minus 3 on the bottom. That's 6 over 1, which is 6. So that limit should be 6 there for D.
Could you explain 4a?
All right, 4a was requested. Okie dokie. So let me just see here if I can make this just a tiny bit smaller. I don't know if I can. Come on now. Okay, so 4a. All right, so can we, okay, so find the following limits or state they do not exist. So if we put in negative 1 here, obviously that's a problem that gives us 0 cubed on the bottom. That's no good, right? Now, can we factor a common factor here? Well, this is already factored, isn't it? The function looks like this, right? So that's already factored. So we can't kind of do that manipulation. So how are we gonna do this? What are other options?
Expand it.
Okay, we could multiply this out and expand it. Okay, we could. Why would you do that, or what would be the benefit of that? Okay, you could expand it. That wouldn't help you though, because what you want to do is you want to try and cancel out a common factor. You can't do that, and you can't factor it anymore. So expanding out will just be a little bit extra work, and it's not really going to help you sort of get rid of this little problem. So what do you think?
So you take the 2 at the top and you turn it into 4h plus 2.
Oh, sorry, we're on A.
Oh, never mind.
You're talking about C there.
Oh,
I could do C2 later.
I have A as well.
Um,
You can't do anything.
So okay, so mathematically here, you just look at this, there's nothing to factor out, which is what our prime goal is. You won't have a graphing calculator, but if you have a graphing calculator, you could graph this and see what's happening, okay? You could graph it and see what's happening as x approaches negative 1. What you also could do, if you didn't have a graphing calculator, this was staring you at the test, what you could do is you could just say, okay, I'm going to test out a number that's really close to negative 1 on either one side or the other. You probably should test both sides, but you could literally pick a number like negative 0.99 and put negative 0.99 in here and in here. Actually, you just need the one spot on the bottom there and then cube it, right? So you could go ahead and kind of, it's not trial and error, you could actually just test that out and see what those numbers come to. So you could try this. You could, negative 0.99 minus 6 divided by negative 0.99 plus 1 cubed. And you could evaluate that and then do one that's just on the other side of negative 1, so negative 1.01, right, minus 6, and so on. And if these are very close to the exact same value, then you probably have a limit. If they are not close to the same value, like if one goes to negative 1 and one goes to positive 1 or something like that, that's not close at all. So you might have a different limit. So that's another way you could do it. Then you might have any other options, because there are other ways to do this, but do you have a question about this? Thought about this?
If we do it like that, do we just cite iteration as the method?
Sure. Yeah. Just kind of, it's not really trial and error. It's just kind of the manual. Well, yeah. It's just, yeah, what you would call it.
Which way you slice it.
Yeah, I'm not sure if iteration is the exact right word, but
Educated guessing.
you're testing multiple hypotheses here and gathering the information from that. Yeah. You guys like my new mug? Max.
Max.
Yeah, Mr. Maxwell.
Oh!
That's my name. Okay.
Is your name Max?
So yeah, if you just do those, this comes to a negative very large number here on this side, and then a positive very large number. So they are definitely not coming to the same number at all. Therefore, that one does not exist. Okay, and if you graphed it, you would see that as well. That would be going the opposite direction. So did someone say you wanted to see C done?
Yeah.
All right, C. C. Let's do C. Okay, so 100%, 100%.
Yeah, no, hold on.
All right.
Yeah, synthetic division.
All right, so C, good idea to actually simplify the top here by getting a common denominator. So I don't know if you guys did this, but 2 plus h over 2 plus h. If you, if you multiply just this even by that,
Yeah.
right? So you'd have the limit as h approaches 0 of 4 over 2 plus h minus 4 plus 2h over 2 plus h, right? If you just change that, all over h. Now this is 4 minus 2h, so it's negative 2h over 2 plus h, all over h. And if you're dividing by an h or dividing by a fraction, write that as a fraction, flip and multiply. So that actually becomes the limit as h approaches 0 of negative 2h over 2 plus h times h. And that's great because this h as a factor would divide out with this h as a factor. Then you have negative 2 over 2 plus h, which now you can just substitute your h in place of 0 in for h. 2 plus 0 is negative 1. For C. Negative 1. Okay, questions? How did you do that? Right here? How did you get the what? Sorry? Okay. So, yeah, just something to keep in mind. If you have like 2/3 divided by 5, that's always the same as 2 over 3 times 5. Okay, so if you're dividing a fraction by something, it's just like putting it in the denominator as a factor. And that's because this 5 is actually 5 over 1. So when you flip and multiply, right, it's 2/3 times 1 over 5, which is 2 over 3 times 5. So that's what I did here. I took this h over 1 and I multiplied it by 1 over h. It's the same thing as doing that. Okay, you're welcome. Anybody else?
Wait, it's the bottom one you flip and multiply, right?
Yes, you flip and multiply the bottom one. Flip the bottom one, multiply.
Flipping multiply, man.
Yeah, don't get frustrated now. Don't get frustrated with him. Okay?
Yikes.
Don't be,
I actually
don't be mean. Don't be swearing at him.
say.
Flip and multiply, man. Okay. We all still friends here? Okay, debatable. Any other questions about 4? I do have 6 here, but that's a big one. So, are you guys ready for 6 yet, or do you want me to pause?
Maybe
All right, so let's just skip to 10b here because we're going to get some practice using Formula 1 and Formula 2. So when do you need to use the formulas? Well, when you're just given an equation like this of the position time function or something like that, then if you're trying to find instantaneous velocity, then you use one of Formula 1 or 2. So remember, back here, if you're just given a limit question, don't force this into Formula 1 or 2, just evaluate it. But if you're not given the limit at the beginning and you're saying, hey, find instantaneous rate of change, that's when you use Formula 1 or Formula 2. Okay, so Formula 1, let's just say, Formula 1 is going to be, remember, limit as x approaches a, and here you go, f of x minus f of a, and on the bottom, it's the x, same as the variable up there, minus a, same as the variable up there. So here, when t is 1, that means a is 1. Okay, so this is the point, the x value of the point of tangency, or here the time, the t value of the point of tangency, okay? Instantaneous velocity. So we will do this by taking the limit as x approaches 1. The f of x is going to be 200 minus 4.9 t squared minus f of 1. So what's f of 1? Well, that's going to be 200 minus 4.9. What's that? 195.1? 195.1. All over, oh, I guess, sorry, this should not be x here now, this has to be t, right? So t minus a, because this should be t here, sorry. T is the variable we're using in the question here. So as t approaches 1, or I should say t minus 1. Okay, I think we got that now. So what we want to do is we want to gather like terms and that sort of thing, and so that we can try to simplify the top a little bit. So as t approaches 1, I'm going to have negative 4.9 t squared here. And I'm going to have, let's see, oh yeah. And I'm going to have what? I'm going to have 200 minus 195.1. So that's going to give me, I guess, the 4.9, right? So positive 4.9, right? T minus 1. Okay. So let's factor now. So now what we have to do is we have to factor. Well, I see I have a 4.9 as a common factor. No problem. I don't really want a negative in front of the t squared because it's not as easy to factor. So I'm going to take a negative 4.9 out. Then I'm going to be left with a positive t squared, and that's going to change this side to a minus 1 all over t minus 1. Okay. So we're getting close now. You see the t minus 1 is going to be a factor of t squared minus 1, right? That's a difference of squares. I can factor it. I am going to have a common factor in the bottom. So limit as t approaches 1. Now the negative 4.9, right? You can't actually bring that right out because it's just a constant. So I'm going to do that actually. You don't have to. You can leave it in there, but you can also just leave it out front. So this is now going to be t plus 1 times t minus 1 over t minus 1. So here's where you see now that we've factored that difference of squares that I have these two cancel out. And then I've got negative 4.9 just sitting out there. And now I can evaluate this limit, what's left over. And so that's just going to be 1 plus 1. So negative 9.6. Okay, is the value here. And instantaneous velocity, well, we're dealing with meters and seconds. So that velocity is going to be meters per second. Okay, so that's the answer we get with Formula 1. Let's just, let's do Formula, wait, 9.8, my bad. 9.8, 4.9 times 2 is 9.8. So that's what we get with Formula 1. Let's check Formula 2 now, okay? I'll do a different color. Let's do blue. form 2. And that's going to be the limit as h approaches 0 now of f of a plus h minus f of a all over h. So we don't have to do as much factoring, but this is going to be a little more complicated to multiply stuff out. We're going to have to do some expansion. That's going to be a bit tricky. So limit as h approaches 0 here. So remember, a is 1, so we're going to put 1 in both of those. And 1 plus h is going to go here. So that's going to be 200 minus 4.9 times 1 plus h all squared. F of 1, we said over here was 195.1, so I'm going to put that. Whoops, 195.1 all over h. Limit as h approaches 0. So this is going to be, I guess this 200 and this minus 195 can be simplified. We can do it at the same time as we expand that. So it's going to look like this. 4.9 times 1 plus h squared. That's what this is when you expand that out. And then we're going to have 200 minus 195, which we said was this plus 4.9. Okay, all over h. Continuing on, what else can we do here? Well, should I multiply this in? You don't have to, actually. You don't have to multiply it in, because what I see is I see a factor of this first term and a factor of the second term, a common factor there. So again, you could take out a minus or a negative 4.9 out of there. And I'm going to put it over here, negative 4.9. I'm going to take that right out. So that's out of both terms. And that's going to be a plus, actually a minus 1 when it's all said and done. So I have 1 plus h squared plus h plus h squared. And then I have what, minus 1, you see? So I took out a negative 4.9, which makes this a negative and 1. So that's great, because this is working out really nicely, because the 1 and the 1 are gone. The 1 and the negative 1. And now I have only terms with h in it above there, so that's perfect, because I can factor an h out. 1 plus h over h, see? Took an h out of these two terms here. So those h's are gone. Let's divide those out. And then I have negative 4.9. And I can just now evaluate this. So what's 1 plus, if h is extremely close to 0, what's 1 plus a value that's extremely close to 0? Well, that's just 1 plus 0 is 1. So I have 1 plus h is approaching 0. All right, so I see what I did wrong here. I missed a 2h here. Sorry, 2h. So 1 plus h all squared is 1 plus 2h plus h squared. So that's going to be a 2h there, and a this is going to be so that's going to be 2h plus h squared. Take an h out, that's going to be a 2 here. Yeah, 2 here. So that's going to be 4.9 times 2, which is going to be negative 9.6. Things are disappearing on me. 9.8. So we do get the same answer with both formulas, which we should. Meters per second, negative 9.8. All right, just make sure you expand that properly. Sorry. And that's when you use those one of those two formulas. On the test, you might have to show both formulas at different places. You won't have to do both formulas for each question. It'll be questions you'll get to choose, whichever one you like better. So I don't know which one you like better. For this one, factoring right here is not that hard, right? Obviously proved a little more difficult for me to expand this properly. So you might want to opt for Formula 1 here. Sometimes these equations, or these functions up here, are difficult to factor, like if you have a cubed or something, right? So you might want to use Formula 2 if this is not easily factored, right? Or if you get squared or cubed or something more, you got 5 terms or something, you don't want to factor that. Anyways, yeah, so that's that. I probably won't go over all of these questions here for the review, but so 1 and 3 and 4 and 10. Okay, sad. All right, there's a little bit of review there. I would suggest doing number 6, piecewise function type question. And I would also suggest you doing number 8. So just review 1.3 if you want to see a piecewise function like this done. And 1.1 for number 8 if you want to look at how this question is done. So let's check out other links to other videos for this chapter to do these other ones here. And yeah, there you go. That's a bit of review for each chapter 1 exam. And you're going to do great. So that is definitely going to be a big smile.